Hello, AGP students. This is Rob Jensen coming to you today to talk about the SAT May 2018 math test no calculator section, section 3. And so we're going to be walking you through the problems of how we would approach them and in solving them. Additionally, as well, we'll be kind of show you some of the strategies that were distributed to you and taught to you in class, and along with how to necessarily better diagnose questions of things. All right, so let's go ahead and kind of take a look at our first problem that we have here. Let's see. So looking at number 1 here. So looking here, it says Ladarius spent a total of $200 to lease a snowboard and such. So he spent a total of $200 to lease snowboard equipment and things. Well, one thing in kind of looking at this question before we sort of go much further is that we can see we got a word problem here. And then looking at the answer choices, remember it's linear equations that we have. So we have linear equations that are here. And so if you remember, when we see word problems and linear equations, we're developing these. And so in developing, what we mean is that we're trying to say something is y equals mx plus b, which traditionally we're most interested in the slope and the y-intercept. Remember, the y-intercept on the graph is where it so happens to cross this axis when x equals 0. So looking at those pieces, we have this piece of information, total $200 to lease a snowboard during each vacation, each day. So remember when we see this word each, remember if we see each, every, and per, we're traditionally meaning some sort of slope with some y over x of things. He purchased a lift ticket for $44. Ladarius purchased T lift tickets. How much money in dollars did Ladarius spend during his vacation in Winter Mountain with snowboard equipment and lift tickets? So we can see snowboard equipment, which then that comes back up to top here. So that's $200. So we can see, okay, well that has to be the B, because we have to spend $200, and then he wants to know, because that's just a one-time expense. And then within that, how many lift tickets that go for each day. And we can see that within B44. So within that, can't be that because we don't have that, and it has to be that one, which is C. All right. Oh, my apologies. Let's go to number 2 here. Number 2, what we see is we have some polynomials and some expressions of that. We have a bit of distribution that we have to do here. So on these, we kind of like to distribute and cancel at the same time. So if I sort of take this piece right here, okay, and distribute, because I got to distribute the 2 into here and the 2 there, I now have 2q squared plus 2r, right? And so within that, I can see, well, how many r cubes to start off when we see we got these r cubes? Well, I see I only have 1 r cubed here of things. Now let me go ahead and just sort of finish this expression. So this would be 3q squared plus r cubed plus 5r minus 8q, right? And so then we got to add this stuff down here as well. A little sloppy, I understand that. Well, let's just kind of go through. So we see we only have 1 r cubed, so that kind of eliminates this one. We do not have anything to we see we have these 5q squared, so that kind of tells us that, okay, we have these 5q's. But looking at the next expressions, we don't have anything that's multiplying the q and an r together, so we can eliminate b for that reason. We now have minus 8q, so really we're just focusing in on here. We're using our divide and conquer strategies. And so I see I have 2r here, and then I also see I have 5r here, or where is it right here again? So 5r plus 2r is going to give me 7r. And so for that reason, we know the answer choice is going to be D and not C. All right, so let's take a look at number 3 here. It's asking us that it says, which of the following equations represents the line in the xy plane that passes through point 0, 3, so that's an order pair, so that's telling us that's the same thing as x, y, and has a slope of -3 things. Well, slope of -3, we know, again, we're trying to set up an equation at y equals mx plus b. And so overall, this is a coordinate geometry problem. I can't really see that in there. I'll keep that in mind for the future. So a coordinate geometry problem. So slope of -3. So that means C and D have to be out of this one. The things. And then we see that the X here, we can say that this is cube's here and the Y is here. So we know X equals 0. And when X equals 0, that means that's really referencing the Y-intercept of things. And so the Y equals 3. So that means our intercept is at 3. And so that means it has to be B and not A as an answer choice. Okay. Alrighty, so let's look at number 4 of things. I know number 4, this type of problem traditionally gives students some angst. What we see is what we have is a linear equation, but more importantly, we're talking about something of either no solutions or infinite things, infinite. And so remember, our main tip here is we want to eliminate the x's, okay, and be left with either values of some sorts. So this one, it says, if the equation has infinitely many solutions, which the following must be equal to C things. And if you remember infinitely many solutions, that means the values, when you eliminate the x's, will agree with each other. So for instance, if you limit all the x's and 3 equals 3, then you know you have infinitely many solutions that will work there. So let's first start off with distributing the 2's of things. So we rewrite this. So we have 2x plus 2b equals ax plus c of things. All right. And so for this reason, we know that we have, again, infinite number of solutions. So let's bring the x's together to one side of things, and then say as to what would then be with the c and stuff. So we're trying to see which one is equal to c. Well, actually, I'm sorry, in looking at this, we can see that we have a pattern here. We have 2x and ax here, right? Sorts, and what that may happen to be like. And then as well as we have 2b and c here as well. So what we see on this problem is, and remember, we always want to eliminate the x's. Since there's infinitely many solutions, we want to have a constant and a constant together. Things. And so since this is a linear equation, the 2b is the constant on this side of the equation. Okay, so this is the constant. Okay, and this is also the constant. All right, so what we can take away from this is a here has to be 2. So if we rewrite this, we now have 2x plus 2b equals 2x plus c. So again, that a has to be equal to 2. So in doing that, we then know that these values eliminate each other because, again, our ultimate objective is to eliminate x's on these ones. And so 2b equals c, which the following must be equal to c. It's asking us here, which has to be answer choice D for us. Okay, so let's look at problem number 5 here that we have. And so what we can see is we have some foiling or just quadratics and distribution on this problem. And so we can see that what we're being asked to do is that we have to expand on this piece here. Sorry, let me see about that. Try that again. So we have to sort of expand this piece right here. So while I have a little bit more room, and we're trying to condense, we know we have to sort of expand and then contract everything that we have here. So let's don't fall for this trap, but 2x plus 4 times 2x plus 4. So we're going to handle this piece first. So foiling here, we get 4x squared. And we got a FOIL there, which is going to be plus 8x. And then we got a FOIL there, which is going to be plus 8x. And then we have to FOIL there as well, which gives me plus 16. All right, so let's combine these terms. So so now we have 4x squared plus 16x plus 16. And then let's bring this stuff up here back down. So we have to then take this and bring this down. So minus 4x squared. Well, you see, in doing so, we're now eliminating these values, right? So within that, we see, the simplified or expression here. And within that, we see we have 16 is 16. So we're now factoring out this piece, and you're left with x plus 1. So that ends up giving you answer choice A on number 5. Okay. So let's look at number 6 here. All right. So let's look at number 6 here. What we see is we kind of have another coordinate geometry question, because we see we're in an XY plane. And what we're trying to do is predict it. It's kind of a graphing one. So since it's associated with a graph, we've got to be able to use that piece. So one of the main things when doing these is, one, make note of your scale. It looks like we're going by 1 by 1 with each square. So we just want to make sure of that. Recognize our intercept. So that's our y intercept here. And we see that's going to be 1, 2, 3. So the b in this is really equivalent to 3. So let's see which one of these works, because they're not written in slope-intercept form. So we kind of have to manipulate them a bit. So if we move this piece over for A, we now know A is going to be 2y equals 6 minus x, which this is a negative slope here. We also recognize that we have a negative slope here, which we have here, and that looks to be good. And then divide by 2 and divide by 2. So we end up getting y equals, which is equivalent to 3 minus x. So this one checks out okay so far. Haven't been able to, we could probably actually, let's see what our slope would be. So if we chose this point here, and it looks like we're going through this point really. So it looks like we're going down 1. So it looks like we're going down 1, and then we have to go over 2. So the change in y would be negative 1. It'd be, the run would be 2 and stuff. So this is saying y equals negative 1/2. This is saying y equals negative, that'd be 1. So, all right, so we can eliminate A as a potential answer choice on this one. Oh, I totally just wrote that wrong. My apologies. That should be, sorry, when I divided by 2, that would give me negative 1/2 x. Sorry, when I did that. So the answer choice, I'm sorry, is A on this one. So my apologies on that. And so we can see just by going through those procedures. However, going through this, what I would have done, since we kind of have to manipulate these, we almost got to attack them one by one. Once I had seen an element that doesn't work, like if the intercept didn't work here, I would eliminate it and boom, moving on to the next one. And sort of done the same procedure with all of them. We just happened to get lucky that the first one here was actually correct and is mimicking what we have up top here. So A is the correct one on that one. Okay, so let's look at number 7 here. What we have is we have a function table. Okay, so we can see this is a function table. And we have our x values, and we have our f of x, which is also equivalent to the y values, okay, that we have here. And so reading this question, it says, for the function f, the table above shows some values of x and their corresponding values of f of x in terms of constants, so a, b, and c. If a is less than b and b is less than c, which of the following could not be the graph of y equals f of x in the xy plane? So essentially it's saying that if we put in the values of x, then it necessarily will not correspond to what we have here in regards to the values that we have. So what you can really do is when you're given these constants and you have these parameters right here, just make up numbers. Just make up numbers and put them in. And so we'll say a equals, I don't know, we'll say a equals 2, say b equals 4, we'll say C equals 6. And so if I see that essentially if I have x equals 1, then y equals 2, and so we see that's kind of increasing. We see that if x equals 2, then and x could be 4. And we see that's kind of increasing here, and same thing at 3. So we see that what's happened is we have what we call a direct relationship. What that means as x is getting bigger, so are my y values. And so we call that a direct or positive relationship. And so we see a positive relationship here. However, here we see just the opposite. As x is getting bigger, y is getting smaller. So quite possibly this one. So let's double check the rest of them. C, x is getting bigger, y is getting bigger, so that checks off. Here we see x is getting bigger, y is getting bigger as well. So therefore, B is the answer to it. It says because following could not be the graph. So B could not be a representational graph of what's up here in the table. Okay, so what we kind of see in this one is that we kind of have this pattern of sorts. It says, in this question it says if 3x minus 6y equals 9z, which of the following expressions is equivalent to this? So, and our answers are in z here. And we see we got x and y, and we got x and y through all of out here, right? So what we're trying to do is we're trying to develop some sort of pattern that exists between this piece that can be developed into this piece, and then in developing that piece, we can then help to solve what this is equivalent to and such. So first off, let's take what we have, 3x minus 6y, and we should notice within the pattern here that everything is divisible by 3. So if we pull out 3 here, we now have x minus 2y equals 9z, and then divide by 3 here, and divide by 3. And so we eliminate those pieces, and we end up getting x minus 2y equals 3z. However, again, we're not quite done. So that's part 1 of the question. So let's go to part 2 of this question. Well, here we have to figure out what's equivalent. Well, we should kind of be able to notice that this piece here, if we was to square this, so if we say x minus 2y times x minus 2y, and if we FOIL all of this out, we're going to get x squared minus 4xy plus 4y squared. So we notice that this piece is equivalent to this piece up here. And so what this is really saying, well, if x minus 2y times x minus 2y equals this, then the 3z that we have here, we could just say, okay, well, we could say 3z times 3z, okay? And so this is the same thing as this, okay? This piece here is the same thing as this because you can see the equivalency here. And so distributing, we now are going to get 9 because you got to distribute the 3's here, and the z times z is going to be z squared. And for that reason, we can see that number C is the correct answer choice on this problem. All right, so let's look at number 9 here, and something that we can notice off this problem that we have is we see these pluses here, right, in the answer choices. And so that should give us a dead giveaway that we are working with a quadratic formula question. All right. And remember, doing that, one of the very first steps on these sorts of problems is that you want to be able to label your ABCs. Remember, this is ax squared minus bx plus c equals 0. So we can see the a is equal to 1, and the b is equal to -4, and that the c is equal to 2. And so we just need to write our formula down. So we have negative b plus minus b squared minus 4ac all over 2a. And so just plug and chug. So we'll plug this in. So we got negative 4 plus minus, okay, b squared, b again, b negative 4 squared minus 4 times 1 times 2 things, okay? And then this will all over be over 2a, which a is 1, so that's going to be 2. So let's simplify all this now. So negative 4 is going to be a positive 4 plus minus negative 4 squared is going to be 16. So we can see, okay, that's going to be 16. Minus 4, negative 4 times 1, negative 4 times 2 is going to be negative 8. So it's going to be 16 minus 8. And so that's all over 2. And so then that then equals 4 plus minus the square root of 8 over 2. If you can remember, you know the square root of 8 then turns into, say, 4 plus or minus 2 over the square root of 2. That's the same thing as the square root of 8 over 2. Now we can eliminate these things and eliminate those. So now you're left with 2 plus minus the square root of 2. And this just has positive values. So it says which the following is a solution. So it's not asking for the solutions, just a solution. And so C is the correct answer choice. So really not terribly challenging, but it certainly helps to understand that this is what I'm looking at. I understand the formula. I take my values, plug them in, and be able to solve for it. Okay. Now let's look at number 10 here. Number 10 here is something we should be able to sort of recognize, is that this is an exponential function problem. And what we're looking at is, we can see it's got these explanations down here. So this is a modeling question. And modeling questions are basically asking us to interpret what piece of this equation. So looking in it a little bit further, so remember this is going to be y equals a times x to the b. And so we want to identify what piece. So looking, it says in millions, United States for 0 to n, where n is a number of years after 1940. So n is representation of years. Which the following is the best interpretation of the number of 5.77 in this context? Well, we see that 5.77, we can see that 5.77 is equivalent to a here. Remember, a represents what we call kind of like the principal, or what we so happen to start off with. Remember, if we're talking about exponential functions, we have x, and then we have f of x, which is the same thing as y. And we kind of start off here. So we're talking about what is the value at this point. So x is talking about years, right? So we're not really talking about, or I'm sorry, x or n, same thing, this is the same thing, n here. N is talking about years, so anything we're dealing with years is not what we're necessarily talking about. And 5.77 is the principal, or is y, and y is talking about which is the number of farms. It says the number of farms, f of n, in millions. So a is f of n in millions. So we go through and our answer choice. It says the estimated number of farms in millions, 1940. Well, from the beginning, started at 1940, right? Number of farms in millions. So this is all the same thing as y, or what we call here f of n. And it starts in 1940. So boom, there's our answer choice. First one. So that's it. So it wouldn't be, here you see the estimated decrease in the number of farms. Well, certainly, well, there is a, sorry, I guess so, because of 0.98, there is a decrease. We can actually see, well, in reality, this is probably like it's doing something like this with the green line. So because of the 0.98, that's going to suggest that there is a decrease, but we're not making reference to that. That's not what we're trying to do. And it says estimated number of farms in millions in years after 1940. So that would make reference to, like, if we said we had like n equals 10, then we would kind of know that number. So that's not it. I'm sorry. Here, if n equals 10, then that would suggest a number of decrease. So that's not it. Percent by, again, that's not talking about percent. And, you know, and then we're talking about the estimated number of years in millions in years after 1940. Again, if that was something of like, if we had an exact number that would suggest like how many years afterwards, then that would tell us what that would be. The things that would be kind of the total here. That would be the total what we're looking at. Again, we're not looking at y or f of n and stuff, so that's not it. So A is the correct answer choice based off some of the primary reasons that I gave in the beginning. Number 11 here, and what we see, what's going on in that. And so we see that we have a quad here. We have a quad, and then we have a linear. And so when we do these, we want to be able to bridge these expressions together. And so let's make sure the conditions. It says the graph of the equation intersect at point xi where x is greater than 0 and y is greater than 0. What is the y coordinate of this point of intersection? So we want to make sure we pay attention to these parameters here. So bridging them, we rewrite this expression as x squared equals 2x plus 3. I don't want to have a negative x squared, so we're going to move all these pieces to this side. So we can rewrite this expression as x squared minus 2x minus 3 equals 0. We can factor out, and so we know if we have a larger number here, we're going to have the negative 3 and a 1, because negative 3 times 1 gives me negative 3, and when I add those together, I get negative 2. So I now know I have x minus 3 times x plus 1 equals 0. And so my x values then equal negative 1 or 3. Now it says here that x is greater than 0, so we want to be able to use this one. So on the second piece of this equation, popping it back in, we can say y equals x squared, which is the easiest one. It's y equals 3 times squared, which then gives me 9. And so therefore the answer choice is D. Okay, so be sure you're paying attention to this piece. All right, let's look at number 12 here. And 112 here is, we have another quadratic equation, right? And we don't have the use of our calculator, so we might have to get a little crafty on this one. And it could take just a little bit of time, kind of a time suck, I like to say, in regards to getting this one right. We could factor this one. We could try to factor this one, and so if it's, but that there could be a couple different possibilities. You could say this could be 4x something times 1x and something of things, or you could say it would be 2x and something times 2x and something, and because since this is not a prime number, it could be either one of these. So that's a little bit more time consuming thing. So let's go and try to figure out what we can eliminate quickly on this one of things. Let me get a little bit more room here on this area because I don't have a lot. So what I would try to do is to quickly discard what we have in C and D. And so if I had x as 1, just using what we call the trial and error method, okay? If x is 1, then what we have here is that's going to be 4 times 1 squared is 1, so that's going to give me 4, plus 4 times 1 is going to give me 4 minus 3, and we see that does not equal 0, so C is out. Same thing here, we got another positive number, so that's just going to make this bigger, these values bigger, because 3 squared is going to give me 9 times 36 plus 12 minus 3. Yeah, so these are definitely, C and D are quickly gone. And what we can try to do is let's pick the easier one in sort of multiplying of each other things. So if we say we did negative 0.5 times negative 0.5 here on this one. Well, if I have 0.5 times 0.5 again, and this happens to be a negative number of things. So 0.5 times 0.5, that's going to give me 5. That's 5 times 5 is 25, and then that's going to give me, again, that's going to give me 0 and 0. So you see I end up with 0 to 5, and there's 2 decimals, so I end up getting a 0.25. So if I do this, say, because that's squared, right? So that's 4 times 0.25 plus 4 times negative 0.5, and then minus 3. And so what we're trying to do here is we're trying to use process of elimination. So 4 times 0.25, that's going to give me 1. So let's bring that down. We're going to bring this all down here. So 4 times 0.25 is going to give me 1. Plus 4 times, which is essentially negative 1/2, that's going to give me minus 2, right? Because 4 times 0.5 is going to give me negative 2, and then minus 3. And we can see that does not equal 0 either. And so that leaves by default A as an answer choice. So what we're trying to do on this problem is to eliminate answer choices by going with the lowest hanging fruit. And so what I mean by the lowest hanging fruit is like, let's choose the easy ones, let's discard them real quick, then choose the next easiest one and go from there. And otherwise, if B was right, we know B is it because we're using trial and error. We don't have to try A, and we can confidently eliminate A and then even B of things. Okay, so let's look at number 13 here. Number 13, which we see is we have these answer choices, and we see that we have this equation here. All right. So let's read this. It says the equation P, and so if you need to, you can write in Y here, same thing as P, equals 14.7, there's my constant, so B, plus 0.439D, so that's mx. So what we see here is we have a linear equation that's increasing of things. So approximates the pressure P in pounds per square inch exerted on a diver at a depth of d feet below the surface of the water. What is the increase in depth that is necessary to increase the pressure by 1 pound per square inch? So remember, we had pounds per square inch up here and pounds per square inch here. And so we could see these, always use your units and match them together. So what this is saying is that we want P to go up by 1 pound. All right, that's essentially what's being done here, is that we want P, we want this equation to go up by 1 pound. And how to do that? So if D equals 0 in this equation, right? If D equals 0, so D times 0.4, that's just going to give me 0, so that means you have P equals 14.7 plus 0.439 times 0. Well, we know when x equals 0, because remember D is the same thing as x on this one. So if we draw this out, let me draw this out. So we have P over here and we have D over here because P is the same thing as our y and D is the same thing as our x. So when P or when D or x equals 0, we know we're at 14.7. Okay, and we want to get to 15.7. So what can we do? Well, one that we could do is find which value gives me a positive 1 over here to add to the 14.7. Well, looking at my answer choices, what can I multiply 0.439? Well, the easy one here is A. Because when we multiply 1 times 0.439 times the slope, which is 0.439, these cross out, you get this over this, and you get 1. And so A is the answer choice here. So this is a linear modeling question. Certainly, this is a challenging question, no doubt that it is a challenging question, but it can be solvable if you understand what you're looking at, okay? And that's why I think it's so important, especially in these harder linear equations, the modeling variety. You kind of graph it out, you understand which is equivalent to in the linear equation, and then looking and seeing as to how it so happens to look on a graph of things, and sort of dissecting the parts, knowing what you then need to do. Okay, number 14, it certainly looks a little bit more challenging than what it so happens to need to be. It says if 4x plus 4x plus 4x plus 4x divided by 4 equals 4. All right, what is the value of 4x of things? And so looking at this, one of the things we can do is we kind of sum all these that are up top. So 4x plus 4x. So eventually what you do is you get 16x over 4 equals 4. And then again, this is, what you happen to do. And so what we can do, and the key thing here is be mindful of what we're solving for 4x. So 4 over 4, so this is, you can just write it as such. These cancel out and you get 1 things. And sorry, let me try explaining this one again. This one's not, let me try this. So 16x over 4 equals 4. So let's isolate this and multiply by 4. So you get 16x equals 16, right? And so you end up getting x equals 1. But we don't want to make this mistake because it says, what is the value of 4x here? And so if x equals 1, then 4x is going to equal 4. So the answer choice is B. Okay. All right, let's look at this last one that we have here in the answer choices. It says, in the xy plane, the points 2, 4, and negative 2, 4 are the endpoints of a diameter of a circle. Which of the following is an equation of the circle? So, so first what I kind of suggest that you may do is kind of draw out your xy plane of sorts. It's not a very good line. So let's try that again. Let's have some contrast here. So draw that. Let's draw that, the things that we have here. And we see that we have 2, 4. So we can say 1, 2, we can say 1, 2, 3, 4. So we see we're at 2, 4 here. And then we're also at negative 2, negative 4. So we also kind of cross-reference and say 1, 2, and then 1, 2, 3, 4. So we're down here at negative 2, negative 4. And such. So we need to find out what the diameter of this piece is. Okay, so kind of coming through here. All right, and so we want to happen to know the length of this sort of this diameter, and so it's making it as an angle, so it's a little bit more challenging in some ways. But really, if you think about it, since they're reflective of each other, and since they're reflective, then we know that since they're equal distance of the x values, 2 and negative 2, and equal distance of the y values, 4 and negative 4, then our center should be right here in the center at 0, 0. Okay, because again, they're equal distance to negative 4, to negative 2, negative 4. They're reflective of each other. So it can't be these. All right, it can't be these. And so now what we're doing is we're trying to figure out, okay, which one happens to be the radius here. So what you can do is to find the radius of things. Remember of this equation of a circle. Remember it is x minus h squared plus y minus k squared equals r squared. So we have to find the radius and then square that value to get what we're trying to get here. So one of the ways we can find the radius is do it as though we're doing a right triangle, right? And so we know this is 2 and this is 4, right? That's 4. So we know that the Pythagorean theorem, which will tell us here this value of c, that you have, a squared plus b squared equals c squared. So 2 squared plus 4 squared equals r squared, which is, that's what we're looking for. We're looking for r squared here. So 2 squared is going to give me 4 plus 16 equals r squared, which is 20 equals r squared. And there is our value, not C, D is the answer choice on this one. Okay. All right, so let's look at number 16 of things. We see we're in the XY plane, so we're dealing with a coordinate geometry problem. Now, remember, keep in mind with these grid ends of section 3 that if you're struggling to sort of finish this section, we strongly encourage you to start with number 16 and then loop yourself back around to do number 1 and work your way forward, so that those most difficult ones, saying like 13, 14, 15, if you run out of time, you can just guess and get the answer choices there. So, all right, so this one, it says in XY plane, line K passes through the points 3, 1. So remember, that is equivalent to X, Y, remember? And it's parallel to the line with the equation Y equals 5/2 X minus 7/2 of things. Well, if it's parallel, it's saying, what is the slope of line K? Well, quite honestly, this information up here is really irrelevant. It doesn't matter what my intercept happens to be. If the lines are parallel, and so if line K is parallel to this equation, then we know if this one is 5/2 or the slope is 2/2, then we know it's a positive. And so say this is line Y, then line K has to be the same slope as this one, which is 5/2. So for this reason, the answer choice has to be 5/2 or 2.5. So quite honestly, there's no work. We can see that connect together. Okay, let's look at number 17 here. Number 17, it says if the ordered pair XY satisfies the system of equation above, what is the value of X? Well, remember, we have a systems, and we're trying to see what could be a value of X here. One of the things we could do pretty simply is, since we have Y here and Y here, we could just use the substitution method and plug this in that. So rewriting this expression, it'd be 2x plus 3 times 2x plus, sorry, not plus, equals 4. So distribute, so that gives me 6x right there, so 2x plus 6x, so that gives me 8x equals 4 divided by 8, and you see x equals 1/2. And so that would be the answer choice in that one. Or you could grid in 0.5. Either one will work. Okay, so let's look at the next one that we have. And so what we see is, we should notice right from the very start that we have variables that are in a fraction form. And remember, we call those rational equations. And we have four different types that we need to check out. Either it's going to be cross multiply and divide, either it's going to be least common denominator, either it's going to be long division, or it's going to be factoring of things. Remember, those are only 4 types we have. Well, because we have this equal sign, that means we're going to be doing cross multiplication and division of things. So what we can then do within this one of things, so you see cross multiplying, you get x minus 8 times 1, so you're going to get x minus 8 equals, and then x minus 9 times 1 gives me x minus 9, right? Well, again, this doesn't really seem to be sort of working out too well, because if I have, or I must have written, something's got to be wrong with this one. Did I read this one wrong? Oh, that's a negative there, so sorry. So that should be negative, sorry, whoops, gosh dang it, sorry. That should be 8 equals negative x minus 9. That makes sense. The other one was not making sense. So I got to move the x to this side and move this to this side. So that's going to give me x plus x equals negative 9 plus 8. All right, and then so combining those terms, so 2x equals negative 1. Something I should not be having a negative value here on this one. The things. Let me see, what is going on this one? Okay, so that should probably, we'll put the negative here, the positive here. So I made the mistake, I apologize. And so, see, I was working and I was getting a negative for an answer choice. So that tells me clearly that I was doing something wrong here. So let's delete all this real quick. as you can see. So sometimes this does happen, and I made the mistake of putting and assigning the negative to the denominator, and said it should have been to the numerator and stuff. So let me try this. So that should be, so the negative should be, sorry, negative should be assigned to this one, because that is the -1 times -8 and x minus 8. So this should make this a negative here and make that a +8. So let's try that again. Let's try that again. So that's going to be -1 times x minus 8, so that you guys can see a little bit better. So my apologies on this one. So x minus 8 equals, and that's going to be a positive, so that's going to be times 1. That's going to be x minus 9. So now distribute the negative. Now that's going to make that negative x plus 8 equals x minus 9. So we want to then move this piece over here and then move the 9 to over here. And so that's going to be a +9. So now we've got 9 plus 8 equals x plus x. So we've got 17 equals 2x, divide by 2, divide by 2. So what you end up getting is x equals 17 halves. There we go. That's the correct answer choice. My apologies. But again, if you're working this out, this is really a good case of that. If you end up getting a negative on a grid end, that should automatically make you check your work, go back and see there and stuff. What I should have done to the start is I should have distributed this negative to the top and made that positive, and then kind of cross that out. So as I'm multiplying, I can see what's going on there. Okay, let's look at number 19. So it's suggesting to us that two acute angles of a right triangle have degree measures of x and y. If sine x equals 5/13, what is the value of the cosine of y? So I always suggest that when you're dealing with the trig and things, that you are drawing out and labeling your legs. So let's draw a triangle. Let's see here. Let me draw my triangle. Try to make it as neat as possible. Okay. And so we have here, we know that's 90 degrees there. And so we know if sine x, so we're going to say this here is x, okay? And so if sine of x, which to me, remember, equals opposite over hypotenuse, which then in this case equals 5/13. So opposite would be this leg, so that's 5. The hypotenuse would be 13. Now remember, when we're looking at right triangles, we should always be checking for first is our triples. And this is a triple, so that means this other leg instantly, without having to do any additional work, is 12. Okay, so what is the cosine of y? Well, if that x, this means this has to be y, right? X, y. And so if we do the same thing, cosine of y is going to be the adjacent over the hypotenuse, right? And so if the adjacent leg of y is now 5, and the hypotenuse is 13, so you can see really this is just plain on complementary angles here. If you notice that from the start, you wouldn't have to do all this work. You could just say that the answer choice is 5/13 if you picked up on the fact that we are working with complementary angles. Okay. Alrighty. And let's look at the last question here that we have. So the last one this is kind of uncommon. We have imaginary numbers, and what it wants to know is in the equation above, a and b are real numbers. We see a and b are right here, right? And I equals the square root of negative. What is the value of, we just want to know the value of a here, which is, that's the, so not the coefficient attached to the imaginary number. We just want to know what the a, or the constant here that's attached to the imaginary number. So we got to FOIL this out. We got to go here, and then here, and then here, and then here thing. So first step, 15 times 6, that's going to give me 30, 60, so that gives me 60. 15 times -3i is going to give me -45i. -4i plus, or -4i times 6 is going to give me -24i. And quite honestly, we're not really interested in this piece, because again, we don't care about the bi piece. We don't care about that and stuff. And then lastly, -4i times -3i, so that's going to give me -12i squared. Now, remember, I squared equals -1. So anytime that we see I squared, we have to replace -1 into that spot. So let's rewrite and simplify these terms. That's going to be negative 69i. Again, we don't care about this piece, quite honestly. So negative 12, and then what we're going to do is we're going to pop in the negative 1 here, multiplying those terms. So really, we just want to bring this piece down. So that's 60. Negative 12 times negative 1 is going to give me positive 12. So the answer choice is 72, which that's the equivalent of A. Things. If we was to really write this out as an A plus BI form, so if we was writing out A plus BI, it would be 72 minus 69i. But we don't care about this piece. We just care about this piece for this problem. Well, thank you so much. Appreciate your time. Certainly, I hope you were able to get some usefulness out of this video, and we'll have the section 4 up for you soon. Thanks. Bye.